So in the last class, we have seen that the maximum bending moment, okay, this and all due to wheel load, the wheel load and the self weight. Okay, so the maximum bending moment is 676.16 kilonewton meter. Okay, and the maximum shear force, and the maximum shear force we have calculated that 377.35 kilonewton. This is all about our wheel load and self weight. So next, due to lateral load. Okay, so because of lateral load we can have the maximum bending moment. We calculated that 21.97 kilonewton meter. So I'm going to use this as mz and this will be my. Okay, and similarly this is vz and vy. Okay, then maximum shear force due to lateral load is equal to 14.06 kilonewton. So this is vy. Okay, so this is all about our moment and shear force values. So next, what we are going to do? So we are going to choose trial section. Okay, so selection of trial section. So actually our trial section have two things. That is our gantry girder have two components. One is I section, that is beam section. Okay. So I already said over that we need a channel section. Okay. So this channel section is going to act like a platform for the rails. Okay, which means here the wheel, crane wheel are moving in this direction. Okay, so we have to ensure this rail section. Okay, for the proper movement of the wheels. Okay, so it consisting of on channel section, then on I section. So these components will be called as gantry girder. Okay. So first we have to select the section, that is based on we are having some requirements, that is the approximate depth of the section is equal to L by 12. So the span of the gantry girder is 8,000, that is 8 meter. Okay, divided by 12, so it becomes 666.66 mm. So we are going to choose approximately 600 mm of the depth. Similarly, approximate width of flange. Okay, this is nothing but L by 30. So 8,000 divided by 30. So it becomes around 266.66 mm. So we can say 300 mm. Okay, so that we have to choose the I section having the depth of 600 mm, and we are have to select the channel section have the flange of 300 mm. Here for the I section, the as it is the dimension we are going to, but channel normally we are going to have in the handbook in this direction. Okay, but this channel section with respect to YY and XX, we are going to rotate it. Okay, like in this position we are going to place it. Okay, so if I'm going to have, this is height of channel section, so this height becomes breadth for the gantry girder. Okay, breadth of the gantry girder. So likewise we have to choose the section, so that the hatch of the channel section will becomes 300 mm. Like that we have to select a section from the handbook. So let us select the section from the handbook. So I will share the handbook for you. So first we will select the I section. So roll the steel IB. So preferably we should go for ISW. Okay, that is Indian Standard Wage Beam. Okay, so ISW. Okay, we can choose the section. Okay, now ISW 600. So we can choose this section ISWB 600. Okay, so that their properties are displayed here. Okay, so those properties we will note down. So here, so this section we are going to choose. So its area is centimeter square. Okay, now we have to write it in mm square. So 17,038 mm squared, and height is equal to 600 mm, so it is satisfied. Breadth of flange is 250 mm, then thickness of flange is 21.3 mm, then thickness of web is 11.2 mm, then IXX and IYY values they have given. Okay, so these things we have to note it down along with our what is remaining properties. Okay, so the remaining properties in the sense, so the CYY and CXX values, so those things and all we need. Okay, now so those values we are going to take it out. Okay, so root radius R1 is equal to 17 mm. So those things we have to take it. So next we have to go for channel section. So here our channel will be available. So with respect to channel, the height is equal to 300 mm. That is our requirement. So that kind of section we have to choose. So it is weight beam, here it is medium channel section we have to choose. Okay, so this section we can choose. So ISMC 300, okay, at 35.8 Newton per meter weight. Okay, kg per meter. Okay, so that its cross sectional area is 4564 mm squared. Then the height h is equal to 300 mm. Okay, then the flange, breadth of flange is equal to 90 mm, then thickness of flange is equal to 13.6 mm, then thickness of web is equal to 7.6 mm, then CYY, that is the radius of gyration, center of gravity, that will be acting at 23.6 mm. Then this is our moment of inertia, that is Ixx and Iyy. So Ixx we are going to call it as Izz. Okay, so these values we have to note it down. So first let us note it down these values. Okay, so select ISMWB 600 at so the properties of the section I and channel. First one is area, so 17038 mm square. So for channel section it is 4564 mm square. So this is all about from steel handbook. Okay, steel handbook. So this is as per the requirements of whatever we have seen. Okay, and next thickness of flange, that is 21.3 mm, then 13.6 mm. So another thing, thickness of web, so it is 11.2 mm, and here it is 7.6 mm. Next breadth of flange, it is 250 mm, and here it is 90 mm. Next height, okay, that is 600 mm and 300 mm. Okay, next IZ value, okay, 106,198.5 into 10 to the power 4 mm power 4. Similarly here 6362.6 into 10 to the power 4 mm power 4. So next IY value for I section is 4702.5 into 10 to the power 4 mm power 4. So here 310.8 into 10 to the power 4 mm power 4. Okay. Next to root radius R1 value for I section is 17 mm, and the CYY value, that is center of gravity position, for the channel section is 23.6 mm. So these are all the values we need. Okay, so with respect to that, so just I'm drawing the sections here. So this is 90 mm, and the total height from here to here it is 600 mm. Okay, this is 250 mm, and the thickness of flange is equal to 21.3 mm, and here the thickness of flange is equal to 13.6 mm, and the thickness of web is equal to 11.2 mm, and here the thickness of web is equal to 7.6 mm. Then height is equal to 300 mm here. Okay, then CYY of the section, okay, which is nothing but the centroid of the section for the channel. Okay, not for everything, only for channel is CYY is equal to 23.6 mm. So this is what our sectional properties. Okay, So now we have to calculate what is the requirement, okay, that is ZP value for the required section modulus about the load, okay, now with respect to the load. So 1.4 into mz by Fy, this is the formula. So 1.4 into mz, we noted that 676.16 into 10 to the power 6 Newton mm divided by Fy value is 250. So it becomes ZP Z required is equal to 3786.5 into 10 cube mm cube. Okay. So whatever we have calculated, okay, no. So here